lot of entrepreneurs and designers, because they want to get a very fast quote, they want to get a cheap quote, they just make a beautiful model in their CAD model, send it out and forget this information. When you pour about 400 degrees Celsius hot melted aluminium into a mold, then it will cool down, and it will not cool down homogeneously. There might be some air inside. The air will go out. And one of the key elements when we do die casting products are the control of bubbles on the surface, so that we do not have the bubbles where we don't like them to have. So in every metal product, or in every product, you have areas where you really care that your surface is beautiful. And then you have areas where you don't care so much. To give an idea, areas which are inside your product, you don't really care about the surface because you have some screws. When it's outside, when it's visible, when it's touchable, when you put a paint on, you want to have a very smooth and proper surface. And that's why when you design the mold, the way you design the mold, when you inject the aluminium, you have to think about how the air gets out, and where it gets out, and you want to avoid the air to get stuck in the mold, because that's where you have bubbles later on. And when we do a die casting mold, we usually start with the gate, where we let the aluminium go in, and we have air vents where we let the air go out. And then we think about the pressure, and we make sure that the aluminium can flow properly through the mold, so that there's no air getting stuck inside where we don't want it. And then afterwards we have to cut off the air vent parts. These are aluminium sections that we don't want, and we also have to cut off the gate. And the cut typically is never perfect, because it's a manual cut, or it's a press, or you have some remaining. Now, these cut-off points, you need to make sure that they don't interfere with the function or with the cosmetic effect of your product. So you have to choose these positions wisely, both from a mold perspective as well as from the design perspective. So that's why designers and manufacturers have to work together. And if you don't consider this, and you just make your beautiful 3D shape in your 3D and your CAD model, and you send it off for getting a quote, and you choose the cheapest factory that gives you a quote on this, you're very likely to have some surprises. Another item is that when you make the mold, you have to remove the item from the mold. These are called ejectors. The robot or the machine is pushing the part out of the mold. So since the aluminium at that time is not completely hardened, you will have marks on these ejector points. And these ejector points you have to choose so that the mold, the part doesn't get stuck in the mold and has some scratches. But also you have to accept that these ejector points will create marks in your part, and will also have some burr around it, maybe, if it's depending on how it's looked, but usually there's some burr around it. And you don't want these parts to be in the area where you want your part to be very beautiful. So the mold design has a lot to deal with the manufacturing process, but also with your design targets. So what I can recommend from Celinius, after seeing this for more than 20 years, we usually say when you have your 3D model, you should define A, B, and C surfaces. A surfaces are those surfaces that you want to be perfect, that you really care in your design, which are visible, touchable, that will interact with your user, or that interact with other parts where your accuracy has to be extremely high. Then we select B surfaces. B surfaces are the surfaces that are still visible, but not in the prime focus of your application. That could be, for instance, edges underneath, or that when you really move your head down, then you can see them, but you don't really see them very obvious. So like my microphone here, we have the side, this one is an A surface, this one is a B surface. This is an A surface, maybe here behind there, this is a B surface. And then we have C surfaces. C surfaces are things that are inside, surfaces that you don't see afterwards. And that's normally the C surfaces are the points where we like to put the gate on, where we like to put the air vent on, where we like to have the ejector points on them, so that those surfaces don't matter. But a lot of entrepreneurs and designers, because they want to get a very fast quote, they want to get a cheap quote, they just make a beautiful model in their CAD model, send it out and forget this information. And that's my recommendation, to think about this, to define it, then communicate this if it's a presentation or something very close, just to say, okay, D surface, that's my A surface. That's what I want to be really good at. B, yeah, we can talk about it. C, make a proposal where you want to put your ejectors and other features on them to make sure they don't interact and what will impact. And then we need to have a communication between the designer and the mold maker. because the mold maker has other considerations. He needs to make sure the mold can open well, it can remove the parts of the mold don't break easily, they don't like sharp angles because they are expensive to make, all those things. So there will be a lot of negotiation if you do it right, and this negotiation is not a waste of time, because this negotiation will significantly influence the price of your tool and also the lifetime of the tools. The lifetime of a tool usually is measured in number of shots, meaning the number of time you put the aluminum in and you put the part out, and then how many shots the mold can sustain without the need to repair it. And if you think about per unit cost, this repair is not for free. Even if your maker will not charge you for it, it will charge you over the unit price, so it does influence it. So doing this very detailed negotiation is good.